All right, ladies and gentlemen, this is day 2 of basically applying systems of linear equations. We're going to be focused today. Yesterday, we were focused on determining the best method to solve. And today, we're going to be focused on, we will write. Is it not sharing? Okay, that would be helpful. All right, let's go with that. Thank you for helping me with the obvious. Oh. Okay, better now? We can see? Oh, there we are. Thank you. Okay, man. Okay, so today, day 2, we will write systems of equations from word problems, from real world scenarios. That's always kind of a funny phrase to me. Because everybody always buys 100 watermelons at, X dollars and all this kind of stuff. We will write systems of equations from real world scenarios today. That's basically what we're going to be doing. Okay. Anybody need more time on that one? Does anybody need me to put it on the projector? Okay. Then I'm going to move. Yes? Okay. Go ahead and do that really quick. All right, let's go ahead. Let's get in here. We did those yesterday, and we're going to be starting with example 2. Got it. Thank you, sir. Okay. So here we have the top line represents the cost of renting a car from Ace Car Rental. And the bottom line represents the cost of renting a car from Star Car Rental. Okay, we're going to write a system of linear equations based on the information in the graph. Okay, so I'm going to go ahead here. The blue one is the top one. That's Ace. So let me kind of just write that right there. And when we do this, I think writing it in slope-intercept form, it tends to be the easiest. Right? And so I just start off with my y-intercept. Now, keep in mind, I think the big thing is, hey, you have numbers on the side, right? Be aware. How much is each little line going up by? And so actually 10 is a good guess. I mean, we're going from 40 to 50, right? But notice that that's 1, 2 lines that's taking it to go up 10, right? So we take the 10 and we divide it by 2 and we get 5. See how that makes sense? You got 40, 45, and then you got 50, right? So that means that my y-intercept is going to be 45. And then we're going to look at our slope, okay? Now we want perfect bullseye points, okay? And when I look at this right here, they seem to all be perfect bullseye, but I hope that nobody would answer that the slope is positive 1, right? Because it's not just going up by 1, it's actually going up by how much? Yeah, 5 plus 5, because each one is up by 5. And now we got to look at the x-axis. That's my rise. So I'm going to go ahead here. I'm going to put m is equal to rise over run. If you need me to write bigger, let me know. But that's positive 5. Okay. And my run is, and feel free to put it in the chat. You got to look at how much each one is worth, right? So we're going from 40 to 80 with 2 lines. Okay. And so that's going to be from 40 to 80. That's like going up by 40, right? And we divide by the 2 lines and we get each line is increasing by 20. So that's going to be plus 20. So that is 5 over 20, which when you reduce it is actually 1 over 4. And that is going to be my slope. Got it? And this is for Ace. Now you're going to do the exact same thing, but you're going to do it with Star. And I'm going to tell you something, okay? When we're looking for these perfect points, like that looked pretty perfect and that looked pretty perfect, but then this one is not. So I know it's not going up 1 over 1, you know what I mean? So let's use these 2 points so that we're all on the same page. This point right here and this point right there, which makes for one ginormous triangle. Yes? All right, so go ahead. If you're watching this as the video, go ahead and pause, and then when you got your answer, come back. Right? And those of you with me, so Hussein, go ahead and share with me, what is the y-intercept? Because we're doing this, I want to know what is the value for B for the bottom line. No, sir, it's where this bottom line touches the y-axis. What is the value of this point right here? Here's 30, here's 40, and it's right in between.
35.
Yes. Okay. So we have that. And then our slope. Okay. So let me talk to, Lyle. What was, because see how I did that large triangle, right? What is the rise of this large triangle? How much is it going up by? If you need a hint, let me know. Very good. It is 65. And you could count it by fives, right? Or another way that might be a little quicker is that you just say 100 minus 35, right? That's what you did. Good. And so that's basically 65, right? That's our rise. Okay, that's going to be 65. And then over the 65, our run, let me talk to Miss Martinez. Chloe Martinez, go ahead and share with me, what is my run? $220. Let's see. Yeah, it's right in between the 200 and 240. So that's 220. Okay. And we're going all the way from 0, right? 0 to 220. That looks like definitely over 220. So that's going to be 65 over 220. It is a positive slope. And you know what? I'm going to put it in my calculator, which I already did right here. 65 over 220 is 13 over 44. Not very nice looking, but you know, it is what it is. So when we interpret this, so we've got one equation right here. Here's our second equation, and this is our slope. Okay, that's 44x. Okay, so we're going to interpret the meaning of each one. I want you to go ahead. I want to see how many people can tell me what does it mean for the bottom red line for Star Reynolds. What does this equation mean? I'm going to give you about a minute, and I'd like for you to type that in. Okay, and I want to look at your answers, and we'll talk about it. So I really liked seeing your responses and whatnot. I thought there was a lot of good things brought up. Let me kind of show you with the blue one, okay? I'm going to show you with ACE. That's the top one, okay? So with the top one, with ACE, we start off, we begin with 45, right? Well, 45 what? What's on the y-axis? Dollars. So that is actually, because we're renting cars, right? And this is the cost of the rental. So this is your initial cost, okay? So for ACE, the initial cost is $45, okay? That's if I drive nothing or I drive a ton. Right up front, they're going to charge me $45, okay? Plus, so for ACE, the initial cost is this, plus they charge. And when we look at our slope, right, that's 1 over 4. That's the change in y over the change in x, right? So we're looking at $1, right? $1 for, no pun intended, there's a 4, right? Miles driven per 4 miles driven. Do you see how we get that? Because that's the change in y, that's the unit is dollars, and the change in x, the unit is miles driven, right? Plus they charge $1 for every 4 miles driven. Can anybody think of another way to say that? How much do they charge per mile? Nope. Nope. Think you were playing. What is 1 divided by 4 if I put it in a decimal form? There you go. So they actually charge, I'm gonna put a little decimal, 25 cents per mile. Yes? And that might be something that they put on their poster, like, hey, come to Ace, we're the best deal. We just charge 25 cents per mile. And then in small writing, they'll put initial charge of 45 bucks. Okay? So that might be something that's kind of, you know, the way you would want to present that. So knowing that, and I thought there were some interesting things in here, okay? Number one, here, one person brought up that they were equal, okay? They are equal, but what is equal? Because this person said profit, right? And I would agree that at 220 miles, what exactly is equal? No, that's not profit. What is this right here on the y-axis? The cost. So at this point, does it matter if I go to Ace or Star? No, it doesn't. Now, if I'm going to drive less than 220 miles, let's say I drive 80 miles, who should I go to? Star or Ace? Star, because that is my good. That is my lower amount. So if I'm driving 80 miles per hour, not 80, but if I drive 80 miles, then this is going to be a cheaper price. This one is actually going to be a little bit more, right? And then as I drive, if I was driving 500 miles, notice how they kind of switch places, and I would be better off with Ace, yes? So knowing that, for Star, you might say something like this. You might say, for Star, rentals, the initial cost is a little lower. $35, but what do they charge? And let's do it per mile. For Star Rentals, the initial cost is plus they charge how many dollars for every mile? I'm just gonna say for every mile. For 1 mile. So go ahead and put in your best guesstimate for that. And ladies and gentlemen, what I would do is I would take the 13 over 4, 13 divided by 44. If you put a decimal right after it, it'll automatically give you a decimal answer. And we're looking at, I'm going to round up 30 cents. Yes? Okay. So basically, that's going to be 30 cents per mile. So 0.30 for every mile. Okay. So as you can see, slightly, a little easier to compare, right? Because you know $1 for every 4 miles or 25 cents, right, for every mile. And so just kind of depending on your needs, you know, if you're trying to compare, you can kind of see, oh, it's a little easier to compare. This one charges more per mile, but the initial cost is cheaper, and vice versa on that. Any questions on this? All right, good. So we're solving the system. Wait, why would I round up? Because I guess from the perspective, and you can make an argument for this, from the perspective of the consumer, right? If I'm trying to budget for this, or are you talking about the actual physical math part of it? Because as a consumer, I'm just going to go ahead and raise it up, you know, because I want to like make sure I have enough money for it. But if you look at the actual number, remember you look after the 100th spot, right? 5 or more, raise the score, and it bumps it up 1 more. Yes? If that had been a 4 or smaller, I would have probably left it at 0.29. Any other questions? Is 5 on the bottom half? What do you mean? On the bottom half of 10? What do you mean?
There's 1 through 5. It's on the first 5, 10, 6 through 10.
Oh, you're talking about the numbers on the page. Okay. You know what? They're not really relevant because I was just kind of chopping it up and redoing things. Okay. Sorry about that. All right, so solving the system and describe its meaning in the context of this situation. Okay, so ladies and gentlemen, we have our two equations, yes? What method do you think would probably work the best? Graphing, elimination, substitution. You can go ahead and put G, E, or S. Graphing. I mean, I normally think of it as like elimination, substitution automatically right off the bat, but hello, solutions live where the lines touch. There, we're done with all our hard work, right? We don't have to do anything else. So when they give you a graph, great, let's use it. So that solution is 220 with a y value at 100. And if I want to know what that's actually referring to, that's 220 miles driven. And this is $100. And so I guess the way that I would say it is, if I'm going to drive 220 miles, my cost would be $100, regardless which company I chose.
Better choice if you're gonna drive more than 220 miles would probably be the Ace.
Yes, if you're going to drive more than 220 miles, you're probably better off going with Ace, right? Yeah. And if you're driving less than, then Star would be your best choice. And so that's exactly what we want you to be able to do, is to look at data and make decisions and be able to make, logical choices based on things. So if I'm going to drive 220 miles, my cost would be 100 miles, regardless of which company I choose. Okay, and if you wanted to add on to that, a better option for this, worse option for that. Any questions on this concept right here? All right, let's talk about vegetables. Everybody's favorite. So we have a roadside vegetable stand that sells pumpkins for $5 each and squashes for $3 each. Okay, pumpkins, $5 each. Squashes, $3 each. One day they sold 6 more squash than pumpkins. Okay. 6 more squash than pumpkins. And their sales totaled $98. Write and solve a system of equations to find how many pumpkins and squash they sold. So let's look at the stuff I highlighted in yellow, okay? And when I look at that data, are you thinking slope intercept or standard? Go ahead and send it in the chat. Slope intercept or standard? Yeah, I agree. You have standard, right? Because you've got $5 each for this and then $3 each for this. It's not just one thing where it's changing, right? And then you have another number that's like a one-time thing. So this definitely lends itself to standard form. Something like, let's make pumpkins X and let's make squashes Y. Okay. And so I'm thinking $5. I don't know why that $5 for the long song just came in my mind. Pumpkins for 5 each, that's 5X, right? And for squash, it must be 3Y. Okay. And here we're totally talking about sales, yes? So this equation is talking about sales. All right. Now, one day they sold 6 more squash than pumpkins, and their sales totaled $98. Okay. Write and solve a system of equations to find how many pumpkins and squash they sold. Okay. So I feel like something's missing. Do y'all feel like something's missing? Right? Because On that day where they sold 6 more squash, was it the same day that they sold 6 more squash? I think so. So talk to me, man. What were you going to say?
Oh, no.
I mean, I feel like there should be 2 total amounts. That's what I'm saying, right?
Totals of squash.
But was it actually the same total for both days? Like it's the same day, right? And so they're telling you, hey, it's 5 pumpkins for this and 3 squashes for this, right? That's $98.
You can find out the total just from the cost, maybe.
Tell me again.
Because, I mean, kind of, but
Yes, go ahead, share with me.
I didn't have an idea how to solve it.
Okay.
Well, we know that for however many pumpkins we have, we just need 6 more squash, so.
That's an equation, right?
Yeah, so I was saying that it would be like 2 different equations, because we could have like, let's say one representing X and 7 representing Y, and then we just figure out what number that would be.
Okay.
And then we would just
So
scale that to
this-
91 to see
No,
what happens.
you know what you know what it is? This is actually an equation all the way. But if they sold more squash, wouldn't that kind of change the total? I figured it out, y'all. Okay, look at this. I was thinking that this needed another total because I had my brain set in that standard form mentality, right? But look at this, 6 more squash than pumpkins. I'm going to go back to my little picture, okay? Because this is just what works for me. Okay, so what do they sell more of? Squash or pumpkins? Squash. So here's my little teeter-totter, my seesaw, right? And the heavy side is your squash. That's your Y, right? And then here is your pumpkins. That's X, okay? And so 6 more means plus 6. Would you agree? Which side do I need to add 6 to make it balance? The Y or the X? X, right? So if I add 6 to this, then I'm going to be pushing down. If I was subtracting 6, I'd be lifting it up, right? So here's my second equation. You see how we have that little tiny phrase is actually one whole equation? And this total goes with this, that when we're thinking standard form, that absolutely is the total, right? And this was an equation all by itself, which is kind of what you were saying, right, Philip? Like the idea is that if you have 1 pumpkin, then you're going to have, let's see, so 6 more squash than pumpkin. Okay, so if you have 1 pumpkin, then you have 7 squash, right? And if I put that in, it absolutely works. 1 plus 6 is equal to 7. Yes? You see that? So my equation works, right? And it's kind of just a different way of thinking about it, but there you go. So now we got our 2 equations. Thank you for helping me think that through. Anybody have any questions on that?
The best one is that I actually wrote that exact same thing down, but I didn't think to myself that would be.
And not everybody has to draw the picture, right? Maybe some of you can just see it, and I'm jealous, but you can actually just see, oh, 6 more squash. Okay, that's just going to be like this, right? And you can actually do it. I have to draw pictures, okay? So now that we have this, we're going to solve. Because I have the variable all by itself, which method do you think is best? Yeah. Substitution, right? Good, Arlana, good. Sonia, yep, I agree. So since we have substitution all by itself, do y'all want me to just let y'all go and see if you can do it?
Yes, please.
Okay. I'm going to try my best to be quiet here. Let's see. All right, so predominantly, the answer seemed to be 1016. So let me demonstrate. Most of y'all got it pretty well. I'm just going to go through this just for the benefit of anyone who did not. We know what Y is, so we're going to replace Y. This is one of my favorite mistakes to make, is to replace the wrong variable. So make sure that you do it correctly. And then I'm going to replace it, replace Y with everything that it's equal to, right? And we're going to distribute 5x plus 3x. And then, so 3 times x is 3x, and then 3 times 6 is 18. Right? We combine our like terms, 8x. And then we're going to subtract 18, 0 pair. 8x is equal to, I believe that is 80. And we're going to divide by 8 and divide by 8. And ladies and gentlemen, we have x is equal to 10. Right? And now all we do is plug it back into here, where we have 10 plus 6, which is 16. And we're done. Okay. All right, ladies and gentlemen, go ahead and try example 3B. Anya makes 14 baskets during her game, and some of these baskets were worth 2 points, and the others were worth 3 points. Okay, those are probably important things. Let's see. Some of the baskets, 2 points and 3 points, and she made a total of 14 baskets. Got it.
The two thing is probably like how many points scored is total, and how many baskets scored.
Okay, so like if we were going to make a table, that you think this one's a good one for table? All right, where we always have like total right here. And you think like one equation is all about baskets and the other one's about points?
Yes.
Yeah. And then what do you think X and Y is?
2x plus 3y for the different points.
For the different points, right? So let's make a, yeah. Well, no, actually, I thought maybe X was baskets, right? But yeah, well, let's see. Let's go to the final question. It says write and solve a system to find how many 2-point baskets she made. So there's 2 different types of baskets. So I think you're close when you say baskets, right? But there's 2 different types of baskets. There's a 2-point basket and there's a 3-point basket, right? And so this one would be, we'll call it X, and we'll call this one Y. So you got X and you got Y. This is a 2-point basket. And why didn't I even write basket? But and then you got a 3-point one, right? So now, what other information have we not dealt with? 14 is a total, right? Would that go over here on the top one or the bottom? Okay. Yeah, I agree. The top, right? So that's going to be 14. Do we have a total for the points? Yeah. Yes, we do. And that total is 30 points, right? So I'm going to go ahead here, put 30. Now I got to figure out, okay, baskets. This is just the number. X is the number, right? So that looks like X plus Y. And then what would this be right here?
2x plus 3y.
Good. Anyone else? Let me see online. Yay, yay, yay. Good job, good job. All right. 2x. Good. Plus 3y, right? Because we got to multiply it times the basket. So if she made nothing but 2-point baskets, if you had 10 2-point baskets, you would have scored 20 points, right? So 2 times 10. All right, great. We got our 2 equations. What method? You could move over the X or the Y, or you could do elimination. What would I was like, that does not sound very enthusiastic. What would I need to multiply times X to make it the opposite, negative 2X? What would I have to multiply times all of this? Yes, ma'am. Negative 2, guys. Negative 2. Y'all see that? So negative 2 times X is negative 2X. Negative 2 times Y is negative 2Y. And then negative 2 times 14 is negative 28. Yes? And then we're just going to do the elimination thing. So that zeroes out. We got 1y. And 30 minus 28 is 2. So that wasn't too bad, right? We got that. So we have 2 3-point baskets. And then I'm going to plug it into my original one. X plus Y is equal to 14. What plus 2 gives me 14? 12. Good, good. So X is equal to 12. And we want to explain this. And you know what? I didn't do it very good on the last one either. We actually, for word problems, we want to be able to talk about it, right? So when I'll go ahead and finish up my thoughts on basketballs, but write and solve a system to find out how many 2-point baskets she made. Well, she made, X is the 2-point, she made 12 2-point baskets. So always go back and make sure, did you answer the question they were asking, right? She made 12 2-point baskets. So I answer that. This one said, how many pumpkins and squash were sold? Okay, well, pumpkins was X. So they sold 10 pumpkins and 16 squash. So that's always a good point too. Just kind of remember, hey, did I answer the question that they were actually asking? Any questions on this? All right, well, I hope I clarified some stuff when it comes to word problems. There's gonna be quite a few on the next exam, guys, okay? So take care, have a beautiful weekend. And actually, if you're watching the video, I hope your weekend was good. See y'all later. Take care.